The weightDriver node now has a new RBF mode which allows to use any number of driving attributes to blend smoothly between any number of target attributes from any number of poses. A standard set-driven key relationship is only able to map one value to another, whereas the radial basis function can interpolate between poses, where each pose is defined by an arbitrary number of input values associated with an arbitrary number of output values. Here I have the translation of the arrow drive the rotation and scale defined by the other arrows. These pose objects don't need to be in the scene and are here just for visualization. The RBF attributes are fairly simple. The RBF solver is just another mode of the weightDriver found at the very top of the attribute editor. Allow negative weights refers to the internal math of the solver, as it can happen that it produces some inverted values on the output. Usually this can be neglected as it's part of the general interpolation. Scale is simply a multiplier for the output values. RBF calculations are usually based on Euclidean distance, which is purely the general distance we are accustomed to. However, if you ever need an angle-based setup, simply switch the attribute to angle. Let's take a quick look at the node editor. Due to the combined functionality of the vector angle reader and the RBF, there are lots of attributes on the node. There are only 3 attributes for the generic RBF solver. The driving attributes, in this case the translation, connect to the input. Each pose is defined by a position and a rotation and scale value. These connect to the pose attribute, where each pose gets the input from the translation and the values from the rotation and scale. Lastly, the output, which connects to the rotation and scale of the arrow. To make the setup of the RBF as simple as possible, the weightDriver comes with an edit tool. The window can be opened by the command weightDriver edit RBF. Since I already have an existing node in the scene, I can select it from the RBF node option menu. To start over, I right-click the menu item and choose Delete Solver. This simply deletes the node from the scene, or you can delete it manually. There are 2 ways to create the setup. The quickest would be to connect all nodes to the solver, but this requires the nodes to be in the scene. The other way would be to collect the values for each pose and then create the weightDriver node with it. I'm going to demo both ways, starting with the connection type. This is almost like creating a driver-driven relationship in Maya. First, I select which node should be the driver and add it to the window. And in this particular example, the arrow is the driven node as well, since the position should drive its rotation and scale. So I add it to the driven node also. The attribute selection should be obvious in this case, translation for the driver and rotation scale for the driven. Now I want to define my poses based on the objects I have in my scene. It's just a matter of selecting these in order and then press connect. The result is a working RBF setup. Since the poses are connected to the weightDriver, it's possible to directly edit each pose. Note that this change is not reflected in the edit window. To see the real values after manipulating the objects, simply select the weightDriver node in the edit window again. To recall a pose, press the recall button. This places the driver at the pose position. Deleting a pose doesn't directly act on the node, but is only considered when the node gets updated. I will get to this in a second. So, this is what the window looks like when you don't create your setup by connection, but by collecting poses. The weightDriver node gets only created when you press the Apply button. This button either creates or updates an existing node. This means when you make changes in the edit window, these are only effective when you hit Apply. With a connection-based setup, this is not necessary, since all pose objects feed the values directly into the weightDriver. But if you don't have a connection-based setup, you need to apply the changes. If I hit Apply now, I convert the connection-based setup to an RBF setup without the connection. Everything is purely value-based, and the values are stored on the weightDriver. Let's also remove a pose for this step. I hit Apply and can directly see that the last pose from before is missing. The other poses are still working. Of course, I can now add a new pose. But since the rotation and scale of my object are driven, I cannot interactively edit them. So I do it by manually changing values. After that, I hit Apply to transfer the changes to the weightDriver. Let's take a look at another example, this time a blend shape setup. Here I have a sphere with 4 blend shape targets. The position of the sphere should trigger each of the target shapes. I select the sphere as the driver and the blend shape node as the driven node. Mind that you can right-click in the attribute list and choose between a non-keyable and a keyable display. Now I select the translate attributes for the driver and the target channels for the driven. Here a connection-based setup doesn't work, but it's also easier to manually add poses for now. The sphere is centered and I want to use this as the rest position, which means that no target shape should be active. Since we are working with blend shape values, the tool can be smart to automatically add the right pose values. If you want to use this, choose Autofill Blend Shape Values from the menu. If this is disabled, you need to set the values yourself. After pressing the Add Pose button, the tool asks me if this is the rest pose. In my case it is. This also defines how the values are set for the poses. You can see now that for the first pose all values for the targets are 0. Now I go to my first pose, which corresponds to the first target, and again I hit Add Pose. Now the pose value for the first target is set to 1 and the others are at 0. The same for the other poses. Now we have 5 poses, each defined by the respective target shape values. After pressing Apply, we get the working RBF setup. So you basically can drive anything from anything. To end with a more practical example, here's how the solver can be used to replace the traditional set-driven key setup to drive some blend shapes based on the position of a facial control. And that's it for the RBF mode of the weightDriver. Thanks for watching. Bye!